Hi friends, from today we are going to start the all graph algorithms and we will cover all important algorithms. Today we are going to just implement the one traversal algorithms. That's are you can see in traversal algorithms there are two types of algorithms. First DFS and other are BFS. DFS means depth first search and BFS means breadth first search. In these lectures we are going to implement DFS. What is the DFS? What is the applications? And after that we will implement these DFS by two methods: recursive approach and iterative approach. First you just do the documentations of the DFS. What is the DFS? So you can see in the depth first search, depth first search is a fundamental graph algorithms, graph traversal algorithm. To traverse we are using the DFS. Okay, that's explore as far as possible along each branch before backtrackings. It means they are go as far as possible. They will start from here and go as far as possible. Okay, means they will start from here, go as far as possible first. After that they will, if completed, after that they will backtrack and go for next. Okay, and if they will complete it, after that go back and go for other sides and go until they will not completed all depth nodes. Got it? That's why they have they are saying explore as far as possible along each branch before backtracking. Okay, and it is used to explore node. Okay, it is used to explore nodes and edge of the graph systematically. Got it? Okay, how does work? How DFS works? Okay, DFS operates using the stacks. We will operates these things by using the stacks. Okay, either explicit or through the recursions. You can implement this either explicit, and in explicit we will using the stacks or recursives. In recursives they are also using the stacks only, but they are not initialized by me. Okay, and follow these steps. These follow steps starts from the source nodes. We will start from the source nodes, means here we will start from these nodes. Got it? And visit the node and mark it as visited. After that, after starting these nodes, we will mark it as a visited. Got it? And then we will go for next nodes. Okay, and move to the adjacent node, move to an adjacent unvisited nodes. If this node will be visited, then we will not again visit these things and go for unvisited nodes. If this will be unvisited, then go for this. Okay, and repeat until no unvisited adjacent node remains, and we will do these works until all nodes are visited, and after that we will backtrack and to the previous nodes and continue exploring other unvisited nodes. Okay, now see, DFS, these DFS are implemented in the two way. First, recursive approach, and second, iterative approach. Okay, we will do both approach. We will implement by the both approach. Okay, first we will see the applications of the DFS. After that we will go for implementations. And DFS is widely used in path findings. If in any questions they have given, you just find the path, then we will use DFS traversals. Example, in maze solving. In maze solvings problems, you there will be given, you need to go from go in maze traversals, which types of problem occurs? You need to go from 1 to n nodes, and by minimum length. Such types of problems will occurs. On that case, you will use DFS. And second is detecting the cycle in a graphs. Okay, you if there will be other nodes, see, you will go for this, go for this, go for this, these nodes. Then for finding the cycles, we will start from this, these go to this, those to this, and again we will go for the visited marks. Then you can say this is the cycle detectors. For that, you are using the DFS to detect the cycles. Finding the connected components in an undirected graph. Okay, if they will say you have a root nodes and find the all connected nodes, then you will go for DFS, go for this, go for this, go for this, go for this, go for this. Okay, they will find all the connected nodes. Got it? For this we are using DFS. Another one is topological sort of the directed cyclic graph. These are the one other types of the sorting. For that we are using the DFS. Okay, and solving the puzzles like the Sudoku in Sudoku and Queens, also you are using DFS. So you can just remember, if you will occur in these types of problem, then think about the DFS. Got it? Now this is the time to implement the DFS traversals. So first, see, okay, this is our graph. Okay, and how they will work in a DFS. So in DFS, first think about the recursive approach. Okay, in recursive approach, we will just go for these root nodes. Okay, and now we will go for these adjacent nodes, and if they will be marked, and you go for these nodes and mark these as the visiteds, true. Okay, and go for the next adjacent node. Okay, this is adjacent nodes, and if there will be node visited, currently this is node visited, so mark, go for these one and mark these visiteds. Okay, and no, these his visiteds. Now go for the adjacents of all. Now adjacents is these node, and these all are adjacents of the one. So we will go for the all. First we will go for this, but this is visiteds. Got it? So we will now go for that, and now go for this. This is unvisited, so we will go for 3. Now go for 3 and mark 3 as the visiteds. So now what is the adjacent nodes of 3? Adjacent nodes of 3 is 1, but 1 is visited, so no go that sides. No any others adjacent nodes are present, so we have traversed all these. So we go call backtrack for this, and now go for the other adjacent nodes of 1, because we have go for 0 have traversed, 3 have traversed. Now adjacent nodes of the 4, adjacent nodes of 1, that's are 4 is only remains. So now go for this, or after that go for this, we will mark 4 as visiteds. And now go for all from 4, so go for all the adjacent nodes of 4, but here only 1 is the adjacent of the 4s, but that are already visited. So go for others, but there are not any nodes have presents. Okay, so go backtrack from here, so because at 1 there are the no any adjacent nodes are remains, so again backtrack here. Now go for 0, but 0 has this side has visited, so go for this sides. and no, 2 is not visited, so go for 2 and mark 2 as the visited. Got it? Now go for these. Okay, because in 2 there are the 3 adjacent nodes, 0, 5 and 6, but 0 is already visited, so no go for this. No, go for 5s, so 5 is unvisited. Now go to 5 and mark this visited. Okay, and from 5s there are the only 2 is the adjacent nodes of this. Okay, so what we'll do, 2 is already visited, so we will know, go for 2 and check for other adjacent nodes, but no other adjacent nodes have remains, so backtrack from here, and here they are at rate zeros, at rate 5s, now only remains 6. Got it? So that's are not visited, so go for 6 and mark 6 as a visited. 6 as visited. Now reach at the 6 and check the any adjacent nodes of 6 are unvisited, but not any nodes are unvisited, so backtrack and backtracks. Got it? All traversals have completed. What will be the final answers of in these traversals? These traversals will be 0, 1, 3, 4, 2, 5, 6. This will be the recursive approach. Got it? Let's just implement this code. You can see there are 7 nodes. I have just initialized codes. There are, you can see there are total 7 nodes, 1, 3, 4, 7. Got it? Now I have made the adjacency lists. Okay, and we'll initialize one visited vectors, and initially all nodes will be false, and total there are the nodes. That's why we will make the visited array of the these 7 length, and initially all will be false. And now we will recursive call for to traversing the graph. Okay, now let's write these functions. DFS recursives. Okay, and initially what will be the nodes? These pass the nodes. Initially we will pass the root nodes that are 0, roots nodes that are 0. That's why initially pass 0 and pass these visiteds. Okay, now pass these visiteds. Now what next? Now now we need to pass adjacency list also. That's why we'll pass these adjacency lists. Got it? Okay, what next? I have passed the all parameters. Okay, now we are going to do recursive approach. So initially if you are at these nodes, then you just mark visiteds, that's nodes. So visiteds of the node make true. Okay, now these nodes are true, so now go for the all adjacency nodes of the. Okay, and if you are marked visiteds, then you can store that node into answers also. So you just write these nodes because you have traversed this. We need to print that's nodes. Okay, now go for all adjacent nodes of this. Let's take IT, and what will be the adjacent node of the nodes. Okay, let's see. Go for inside these. Okay, if IT visitors of the IT will be false, if it will be false, then recursively call for that IT nodes. Got it? So DFS recursives for that IT, again we will pass visitors and adjacency list also. Okay, now I think this is done. Let's run these codes. Now you can see the DFS traversals is 0134256. Now you can match 010134256. I have done these things. This is your recursive approach. Now we are going to solve same questions by iterative approach. What is the iterative approach and how we are using? Okay, so for iterative approach, this is a recursive approach. Now we will implement second, that will be iterative approach. In iterative approach, we are making a stack. Okay, so you can just think, I am erasing these parts, so there will be, I have lots of space to discuss. So we will first initialize one stack in DFS traversals and take that node into a stack, first root node into stacks. Okay, now root are into the stacks. Now go for that stacks and take top elements. Top elements is 0, so we will take 0 and pop in. No, what is the root? Sorry, no root, no node is 0, and go for the all adjacent nodes of the 0, all adjacent nodes of 0, and put into the stack 1 2, and these 0 will store into the answers. Okay, so answers array will be 0 initially. Now again go for the stacks. What is the top elements of the stacks? Top element of the stack is 2, so just pop 2. Okay, now what will be the node? Node will be the 2. Now go for the all adjacent elements of the 2. Adjacent elements of the 2 is 5 and 6, so store that element into stacks. Okay, now we'll store 2 into the answers. After that we'll go for again top elements of the stacks. Top element of the stack is 6, so we'll just erase 6 from here, and now current node will be 6. Now go for the all unvisited adjacent nodes of the 6. Not any unvisited adjacent nodes of the 6 is present, because 2 is already visited, so we will just store that's in 6, and no any node that will push into the stacks. Okay, now again go for the top elements of the stacks, the top element of stacks, and after that we will pop these things. Now current element will be here 5. Got it? And so what is the unvisited adjacent nodes of the 5? Not any elements present. 2 is the adjacent, but that are already visited, so just push 5 into these answer array. Okay, now go for again top element of the stacks. There are the one on, so pop and okay, pop these and store one at hairs. Now go for the adjacents of one. Total adjacents of one is 0, 3 and 4, but 0 is already visited, so we not need to do inside this. Go for these and these only. That's why we will store 3 and 4 into the stacks. Okay, now just one store into the answers array. Got it? Now go for the top elements of the stacks. This is the 4, so we will pop these 4s and here take 4s. Now current node is 4. What is the adjacent unvisited nodes of the 4? No any elements, so after that just store this into the answers. Now go for the top elements of the stacks. This is 3, so pop these and just take 3 at the current nodes. Now current node is 3, but no any adjacent nodes, so no need to do push any elements, and you will just store these in 3 in answers. Now go for the stacks, but stack is empty, so our loop will be break here, so your final answers will be this. Got it? Let's just implement these things in code. Let's write void DFS iterative approach. Now what will be the current nodes? Just pass current node and remaining all things will be needed. So let's take these things. Got it? No, we need to create a stack. And that will be int type. Okay, that will be int type, and that's our s. Okay, so initially what will be inside the stack? Just push root nodes into the stacks. Okay, and root nodes into the stacks, and you will mark visitors of that nodes. After pushing the any nodes inside the stacks, we will just mark that nodes as a true. Okay, now we will traverse these while stack is not empty. Okay, this will work till stack is not empty. Okay, now just take top elements of the stacks. Int just take temp. That's are the s dot top. This will be the top elements. Okay, top elements of the stacks. Now go for the all adjacent nodes of the that's temp. Adjacent nodes of the temp. Got it? If that's visitors of the IT will be false, only then we will do implementations of that. If this is correct, unvisited, then we will store that element into the stacks. I have done. Okay, now where we will initialize the answers, where will we store the answers, means write the answers. After that we will also need to pop the stack elements, okay, elements from the stacks. And we will also just write answers here, right? That's nodes, okay. Now you can see initially I have initialized the stacks and push that current node into the stacks. After that mark this as a visitors. Now go for the whole traversal of the stacks. Initially temp will be top elements, then pop, and after that we will print the that's node, and go for the all adjacent nodes of that stamp node. And if there will be node visitors, then we will push that element into the stacks, and that's all. Now at the place of recursive functions we will just call the iterative functions and pass the root nodes, visitors, and adjacency lists only. And now just run these codes. There are some issues occur. Let's see where this code is not working. Okay, after doing these things we need to mark that node as the true. Got it? Because of this our loops are working infinitely. Now this code will work fine. Okay, this is our answers. You can match these by the dry run answers. 0265 0265 143 143. Okay, this is the your I have implemented. Our answer will be this, and here you can say this is the correct answers. Okay, now you can see these all implementations. These are the recursive implementations, these are the iteratives, okay. And here you can see in recursive codes I have done these in only 2 to 3 lines, and in iteratives approach we need to do some more, we need to write some more codes, okay. And these two are the implementations of the DFS. Now thank you